Hello and welcome to part 5B of my Teddy Ruxpin Refurb series, and this is a continuation on from part 5 where I investigated what causes stuck servos. Now, servos are the motor units that provide the animation for parts of Teddy's face. Sometimes these get in a state where they no longer seem to respond and they leave his eyes or mouth frozen in just one position. Now in part 5 I came up with a theory as to what might cause a stuck servo, and I put it down to a malfunction within the position sensor causing the motor to be driven in the wrong direction. And at the time I was unable to prove my theory one way or the other because I didn't have any Teddy Ruxpins available that had stuck servos. Now here we have two suspicious looking characters that have arrived from the USA, and both of these have stuck servos. So this is me trying to prove my theory with these bears. But unfortunately it doesn't quite go as I planned. So here's the first one. I've taken off his tunic and we can just have a quick look round. But the tape deck, pinch roller, tape heads, everything inside there seems to be reasonably clean. The battery compartment, there's a little bit corrosion on one of the terminals, but nothing we can't deal with. It also came with a cassette already inside, so I'm going to put that back in. So I've attached my crocodile clips with 6 volts of power, and let's just see what's working. I won't turn it up too loud for copyright reasons.
My name is Teddy Ruxpin, and this is my mom.
Okay Teddy, the moment of truth. This is my 39k resistor. If you remember, it's the second and third connectors long. I think the colour coding on this is the same as the bear we were looking at in the other video. Let's try in there. Let's try that one. I think that's fairly conclusive that the resistor has not got these servos going. That's quite disappointing. Well, one thing that shouldn't take long to try is I've still got this sort of working setup rig of this Teddy. So what I'm going to do is I'm going to disconnect his servos, which we know all this circuitry works, so I can take that head away, and I'm going to try and connect this Teddy's servos into that working tape deck. Just checking they are numbered. So let's have another quick try with the resistor. So second and third connector along. That should be enough to make contact. Let's try in there. We're not seeing any servo activity. So let's see what voltage we think is on. -5 volts. So we've been probing the red and green wires, which should be the wires to the motor, certainly according to the wiring on one of these, and we're getting -5.43 volts. Well, I've just wired the servo connectors back into the original board. Oh, let's try it that way round. So back to the original working Ruxpin I can use as a comparison. I'd say when Teddy's not speaking we get a voltage of around about 0 volts and nowhere near that sort of -5.5 volts that we're getting on the other bear. So now let's take a look at this other Teddy. So this one's got the plastic tape deck. Ooh, nicely corroded battery terminals.
Got the first row planted. Mother, I finished the first row of potatoes.
Oh, that's very good, Teddy. Thank you.
You're welcome.
Now get cleaned up for dinner.
Looks to me like this has been apart before. Yeah, look at the material inside the battery compartment. I don't think it would have left the factory like that. And this screw head's disintegrating. No! I think we might be drilling that one out. Oh! No, I've managed to catch it with a flat blade. No drilling on that today. Now, looking under here, you see this variable resistor. That is, I believe, the speed controller for the motor. Now, normally there's a bit of red paint or something which is on there to sort of gum it up and stop it moving, but on this one there doesn't seem to be, so let's have a quick attempt.
Mother, Teddy, what's wrong? Look, the potatoes I planted yesterday are all gone. There's nothing
left but empty holes. Well, that's strange. I wonder what could have caused that.
What should I do? I guess you should plant new potatoes in those holes. Okay, Mom. I filled up all the holes with new potatoes. Then I planted.
So, looking at our other Ruxpin that's got the metal tape housing, that's that little floating board next to the motor is our speed controller, and that variable resistor there is the thing that controls the speed, and we can't adjust this one because it's sort of gummed up with paint. On the reverse side of it, actually the carbon track is completely gummed up with paint as well because it seems to have leaked over onto this side, so there's no adjustment that can be made on this, probably without breaking the connection. Let's see if we can get some measurements on this Teddy's motors.
Then my mother helped me fix up a special surprise for the potato seed.
Potato seed? You mean brown root gatherer?
Well, whatever.
Interesting, that one is also stuck at 5.5 volts.
We went running out to the garden. Our surprise trap had worked our potatoes.
Teddy, I think you should help him out. All right. What is your name?
Oh, I'm Grubby.
Once again, this one is it's the opposite polarity, but yeah, it's around about 5.5 volts.
Yeah. My name is Teddy Ruxpin.
Except when Teddy blinks.
How do you do? If you really want to.
And let's try my resistor fix So in trying to determine a little bit better what on earth is causing these stuck servos, I've got this wired in. That is the motor like you would find on the back of a servo. Because it's been disconnected from the rest of the servo, I've wired the capacitors back in. We've got these, still got these resistors on there. So this motor should be driven exactly the same as a standard motor. So I've disconnected the original motor, and all I've done is I've wired this in to that plug in just the same way. The wires that are going off to the position sensor are exactly the same as before. So wherever this servo thinks it is in relation to where it should be, it should drive the motor accordingly. So let's turn this on.
You are. Grubby, why are we...
And we can see that that motor is decidedly being driven in one direction. So
I said that.
As part of my original idea that the motor was driving permanently and pushing it towards one of the end stops, that appears to be exactly what's happening. But what I don't understand yet is how electrically that's different to what I was testing in video 5, which was just disconnecting this sort of middle sense wire. And I think finally we get to the root of the problem. If I try and measure the resistance across this red and blue wire, which are the two wires to the servo motor, there is no connection between the two of them. And my voltmeter's on the 200 ohm setting. I'll just touch those together to prove that that's the voltmeter is working. We're getting no continuity to the motor. I've just been trying for a few minutes to try and get the top and bottom jaw going by wiggling them from the front. That's not working, so I'm still measuring no connectivity through either of those servo motors. Now for the usual trick, I'm going to separate the foam without ripping it, separating it from the faceplate. I've seen that. That's not even glued to the plastic. So, faceplate, let's disconnect it from the frame. That's just broken the faceplate. Have they glued this on? Might be worth levering this out with some pliers, bear with me. And let's just close Teddy's mouth to make it easier to pull it through. We've still got one clip at the bottom here somewhere that needs disconnected. There we go. I cannot get this to move at all now. Push it through. Now we can get at it. That's better. And let's have a look at the resistance across there now. We still haven't got continuity. I think that servo actually sounds very nice. It's not one of these horribly gravelly, gritty ones. And I can feel there's mechanical resistance on the back of there. So it's not like this one that's had the motor disconnected, which is very easy to turn. And a lot noisier. So it is turning the motor. But we're still not getting any continuity across the motor. And we've now got some continuity across the motor. I actually did that off camera, unfortunately. But all I did was turn Teddy Ruxpin back on, twist it just a few times, and all of a sudden it started moving by itself, at which point we've got no continuity there. What's going on? Have I just broken it again? That's a good question, Teddy. What did you do? Oh, we have got continuity. Well, I'd say from what we've seen today, we've managed to disprove the theory I put forward in part 5 of my Teddy Ruxpin Refurb videos, that you could electrically kickstart a servo back into life with a simple 39k resistor going across a couple of the contacts. It doesn't appear to be necessarily a sensor fault that's causing the problem. It seems to be a discontinuity with the circuit that's driving the motor, and the motor itself is in a position where it cannot receive any current to drive it backwards or forwards, and it remains exactly where it is. The motor, or the circuitry, is attempting to drive the motor, but the motor of course is not responding. So we need that physical mechanical intervention in order to get this in a position where the motor is then making contact again. It was quite interesting that I did manipulate this motor an awful lot without getting that continuity back, and it didn't seem to be till I drove it with the power on and it actually trying to drive the bear that all of a sudden I just moved it a few times and it kicked back into life. I'm just going to try and repeat that operation with another, well, let's try it with the other servos and see if we can get a better idea of what's going on there. No continuity. Let's try with the power on. That's the other servo you can hear. Let's just check there is drive on that servo. So let's back to the voltage. Yep, it's trying to drive it. That's just started working again.
Was doing.
So let's have a look. Our continuity's come back. No continuity. That started moving again. And continuity. I think this also goes against something else I said in one of the other videos, which was that it was probably easier to turn the servos with the bare switched off. Well, it probably is, but it looks from this that will be of no help whatsoever in actually getting these things to move. It's almost like it needs to just pass across that little tiny bit of continuity, at which point the motor will spin up and magically clean itself or brush something out of the way that's then going to give it the conductivity we need. So I've got the first bear here, which has still got stuck servos, and I'm going to take those servos out so we can inspect them a little. This is the top jaw servo. I'm going to mark the polarity. So that was green. And that was red, just to make sure that we get the wires the correct way around when we try it next. So what I'm trying to do now is to just remove all these capacitors, hopefully without doing anything that would come on off. There we go. Doing anything that's going to affect what we're going to be looking at in a minute. And we should now be able to lever that cog off the end of the spindle. And we've now got our motor. So we're fortunate here, the camera's actually giving us a very nice close-up of the motor. We can see there's 3 sets of armature windings, and the electrical contacts on the left and right, we've got these little copper coloured metal prongs inside, which are rubbing on that sort of central drum, which is the commutator for the motor. And we've got the ones on the left are making contact on the top, and the ones on the right are making contact underneath. And having taken it apart for an even closer view, we can see how grotty the commutator is, and also we can see that there's some little bits of unburnt white grease in various areas around the edges, and those prongs look really grotty. Now what I've got here isn't a Teddy Ruxpin motor, this is one I bought recently, so this is a mechanically pretty much identical layout, and we should be able to see in there that that's actually nice and clean. Let's get a closer look. And as well as being all shiny and new inside, notice how much of that white grease there is about. I've done a little bit of research on this that suggests that this is a special type of electrically conductive grease, which has been designed specifically for use in this type of application. But I'll leave that for another video another time. So let's round up today's video with a quick summary. First of all, I think that the theory I put forward in part 5 of the Teddy Ruxpin Refurb videos, that stuck servos are caused by a faulty position sensor, I now don't believe that at all. I think we've completely blown that theory out of the water today. It's more to do with the bad conductivity around the commutator on the motor. So if your Teddy Ruxpin does have a stuck servo, I think one of the best things you can do is actually to push the servo out of the frame before you start to try and turn it, and when you do try and turn it, make sure the bear is switched on and trying to play a tape. In that way I think you've got the best chance of getting it going again. Please take the time to like and subscribe, and hopefully I'll see you again soon on Workshop 1138. Thanks for watching. This is Robin signing off for now.